In this skill, we're going to be learning all about different types of fundamental particles. To do this, we're going to go through a bunch of questions and learn as we go. The first question we have here is about the up particle. Looking at our table here, up is a quark. You can see there are 6 types of quark: up, down, charm, strange, top, and bottom. So what type of particle is the up particle? It's a quark. Which nuclear forces act on the up particle? So there are 2 types of nuclear force, strong and weak. Quarks are acted on by both strong and weak force. What is the charge on the up particle? To figure this out, we just need to look at our table. We can see up has a charge of plus 2/3 E. E represents the charge on 1 electron. So an up quark has 2/3 the charge of an electron, but it's positive. Lastly, we're asked, does the up particle have bottomness, charm, strangeness, or topness? These are different properties that our quarks can have. You can see charm has charm, strange has strangeness, top has topness, etc. Up quarks don't have any of those special extra properties. Now in this question, we're asked about an anti-charm particle. So looking at our table, we can see we have our quarks listed, and then we have our antiparticles or anti-quarks. So you can see for up, we've got anti-up. For down, we've got anti-down, etc. So these are the anti-quarks of our quarks that we have. So anti-charm is an anti-quark. What nuclear forces act on anti-charm? Well, it's still a type of quark, so it still experiences both strong and weak nuclear force. What about the charge on the anti-charm particle? So antiquarks are just like their quark equivalents, but they have the opposite properties. So for charm, the charge is plus 2/3 E. Anti-charm is going to have the opposite charge from that, so it's going to be negative 2/3 E. Also, charm has a charm of plus 1. So anti-charm is going to have the opposite. It's going to have a charm of negative 1. So far we've covered quarks and antiquarks. They experience both the strong and weak force. Antiquarks have the opposite properties as quarks. The next type of particle we're going to look at are called leptons, which is in the second table here. You can see electrons and neutrinos are examples of leptons. So these are particles that aren't quarks. We can see that muon, which is what we're asked in the question, muons are leptons. Now, leptons are different from quarks because they experience only the weak nuclear force, not the strong. Then we can again look at our table to find the charge on a muon. We can see the charge is negative E, the same charge as an electron. We're asked if muons have bottomness, charm, strangeness, or topness. Well, looking at our second table here, there's no other properties listed for any of the leptons. So the leptons can have a charge or not, but they never have charm, strangeness, topness, or bottomness. So the answer here is no. Our next particle we're looking at is anti-tau. So looking at our second table, we can see tau is an example of a lepton, and anti-tau is an example of an anti-lepton. So it's the antimatter version of tau. So what type of particle is anti-tau? It's an anti-lepton. What nuclear forces act on anti-tau? Well, we know that leptons experience weak nuclear force only. It's the same for anti-leptons. They experience weak force only. What about the charge? So we can see tau has a charge of negative E. Anti-tau is going to have the opposite properties from tau, so it's going to have a charge of positive E. And again, it doesn't have any bottomness, charm, strangeness, or topness. So far we've looked at quarks and leptons, which are super tiny particles. Next, we're going to look at hadrons. Hadrons are subatomic particles such as protons and neutrons, and they are built from quarks. So hadrons are made up of multiple quarks put together. Baryon is the first type we're going to look at. Baryons are composed of 3 quarks. So here, 4 students attempt to write down the quark combination of a baryon, and we're asked to figure out which are correct according to the definition. So we're looking for something that has 3 quarks that make it up. So looking down our list, we've got CCD, which is made up of charm, charm, and down. Those are 3 quarks. So that is going to be a correct example of a baryon. The next example we have is UDC, made up of 3 quarks again. Again, that's going to be a correct example of a baryon because it's made up of 3 quarks. The next example we have is D with a line across the top, U with a line across the top, and S. Those lines across represent anti. So we've got anti-down, anti-up, and strange. So that's made up of 2 antiquarks and 1 quark. So that's not correct because we need 3 quarks, not antiquarks in a baryon. Our last example here is made up of 3 anti-downs. That can't be correct because we need 3 quarks, not 3 antiquarks. So that's also going to be incorrect. However, there are antibaryons. So these are the opposite of a baryon. A baryon was made up of 3 quarks. An antibaryon is going to be made up of 3 antiquarks. So again, we're going to look at these 4 examples and figure out which of them could be an antibaryon. So our first example consists of bottom and anti-strange. So that's just made up of 2 things, a quark and an antiquark. So that's not going to be an antibaryon because it needs to be made up of 3 antiquarks only. That's incorrect. The next one we have is up, up, down. That's a baryon, not an antibaryon because it's made up of 3 quarks. So that's incorrect. The next one we have is made up of strange and down. That's just 2 and they're quarks, not antiquarks. So again, that's going to be incorrect. Our last example is anti-strange, and anti-up. So that's made up of 3 antiquarks. So that one is going to be correct for representing an antibaryon. There's one more type of hadron we're going to look at. So we had baryons made up of 3 quarks, antibaryons made up of 3 antiquarks, and finally we have mesons, which are made up of 1 quark and 1 antiquark. So these ones are just made up of 2 things. Let's again have a look at our examples here and figure out which is a meson. The first example is up and bottom. That's not going to be a meson. It's made up of 2 things, which is good, but we need 1 quark and 1 antiquark, and that's just 2 quarks. So that's going to be incorrect. Then we have down, down, down. That's made up of 3 quarks, so that's not correct. Next we have anti-strange, and anti-charm. That's made up of 3 antiquarks, so that's not correct. Lastly, we have up and anti-up. That's made up of 1 quark and 1 antiquark, so that is an example of a meson. So those were 3 types of hadrons. Baryons made up of 3 quarks, antibaryons made up of 3 antiquarks, and mesons made up of 1 quark and 1 antiquark. Our final question here is going to look at a nuclear equation and figure out what's going on in terms of our fundamental particles. So in this question, we've got beta decay, in which a neutron decays and turns into a proton, which releases an electron and an antineutrino. So we can see those particles here. We've got our neutron, our proton, our electron, and our antineutrino. Firstly, we're asked, what is the quark combination in a neutron? Neutrons are made up of 2 downs and an up, so DDU would be the quark combination. Protons are made up of 2 ups and a down, so up, up, down, UUD. Now we need to figure out what happened inside the neutron in this process. So we started with a neutron which had down, down, up. Then we ended up with a proton which had up, up, down. So both the neutron and the proton have at least 1 down and at least 1 up. So one of the downs stayed the same. The up stayed the same, and then one of the downs was changed into an up. So in the process of a neutron becoming a proton, just one of the downs need to change into an up in order for that to form a proton. So we have a down quark that turns into an up quark. That's how we form a proton from a neutron. So either A or B could be our correct answers to describe what's happening. And we also get produced an electron and an antineutrino. So that's telling us that B is going to be our answer here, because it says in the process of a neutron turning into a proton, we have a down quark turns into an up quark, and an electron and an antineutrino are emitted. So our answer here is B. So we've covered a lot here. We've got the idea of quarks and antiquarks. Remember, antiquarks have the opposite properties of quarks. And then we had leptons and antileptons, which work the same way. Quarks experience both the strong and weak nuclear force, whereas leptons only experience the weak nuclear force. Then we talked about hadrons, which are made up of multiple quarks put together. We had baryons made up of 3 quarks, antibaryons made up of 3 antiquarks, and mesons made up of 1 quark and 1 antiquark. Finally, we looked at the process of beta decay, and we saw that neutrons are made up of down, down, and up. Protons are made up of up, up, and down. And in the process of beta decay, where we have a neutron turning into a proton, all we need is for one of our down quarks to turn into one up quark in order to convert our neutron into a proton.